part of the ongoing series named high-risk pregnancies, today I present the Parvovirus B19 infection in or prior to pregnancy. I will start by taking you on a quick tour of the coverage, and aftermath you will opt to revisit the slides on your own. Parvovirus B19 was discovered in 1975 by Cossart, an Australian virologist, while she was working in London. Don't confuse the suffix 19 of parvovirus with the coronavirus in COVID-19. Coronavirus is a helical, single-stranded RNA virus, one of the largest viral genomes known to date, with 100 nanometer in diameter, while the capsid of parvovirus is icosahedral, and the genome is a non-enveloped single-stranded DNA with hairpin structures at both ends and very tiny, up to 26 nanometer in diameter. And the root for the name parvo means small indeed. Parvovirus belongs to the phylum Cossaviricoda, while coronavirus has no distinct taxon above its class, and therefore its phylum is named Incerticedes, which in Latin means undefined, enigmatic. So once we appreciated a basic taxonomy, let's find the place of parvovirus in the world of DNA viruses. In slide 9 of one of my old presentations, named Infectious Agents, which you can find in this very channel, I showed the classification of DNA viruses in happy group, as I do here with the specifics below. As you see, parvovirus is unique in the happy group for being the only linear DNA virus with single-strand DNA, or ssDNA. All other DNA viruses of this group are double-stranded, DS, including herpes, hepatitis, varicella-zoster viruses, cytomegalovirus, or Epstein-Barr virus. However, my former presentation was from 2017, and since then the International Committee on Taxonomy of Viruses has expanded the list to 133 DNA viruses, including a CRES DNA group. Thus, the taxonomy is dynamic, but what remains constant is knowledge of the structure of parvovirus. Also, one needs to appreciate that the two subfamilies of Parvoviridae are Parvovirinae, which infects vertebrate hosts, and Denzovirinae, which infects arthropod hosts. Parvovirus B19 is the only virus of this family that has clinical significance because of its structure, and later on I will explain why. Intruding the human body by respiratory droplets, it incubates for up to 14 days and after manifests with transient aplastic anemia crisis or accelerated hemolysis, which presents, especially in children, a rash on the cheeks named slapped cheeks or the fifth disease. In adults, the parvovirus may complicate into lymphadenopathy, arthropathy, and the rash may spread to extremities, presenting a socks and gloves syndrome. The fetal complications will be discussed later. Age-adjusted prevalence is presented. The disease is highly contagious. Next, I list some diagnostic tests, common serology tests. Some authors also suggest checking the rheumatoid factor in infected adults with arthropathy. Now, I will move to the next slide to clarify why I put here the asterisk sign when I mentioned the globocyte receptor. The reason that parvovirus B19 limits its attack on the bone marrow stem cells responsible for erythropoiesis is that not often it binds well with the surface of its receptor named globocyte or GB4. Due to this structural mismatch, the surface binding does not go well between the receptor and the virus, and the latter is aborted. Thus, GB4 does not provide the anticipated direct entry receptor function. Yet it plays an essential post-entry role, which explains the resistance of rare individuals lacking this receptor to parvovirus infection. Here I list the diseases that should be differentiated from parvovirus infection. Okay, obstetrics, my pony. So put in lay language, if the virus infected the woman prior to pregnancy with already synthesized IgM and IgG against parvovirus, then further infections by this virus during pregnancy will not endanger the pregnancy and fetus. The perinatal risk is high when the pregnant woman gets infected first time during pregnancy. And the most critical weeks are 10 to 25. As you know, the first 8 weeks of pregnancy are under the everything or nothing rule, where the hazard either terminates the pregnancy by miscarriage or does not affect it at all. So the critical period starts fairly from the 10th week, and the adverse outcomes are hemolytic anemia, hemopoietic arrest, and liver damage in the fetus, leading to high output cardiac failure and non-immune hydrops fetalis in the late second and third trimesters. If this happens, the fetus may need intrauterine blood transfusion through the umbilical vein. Maternal complications due to parvovirus are erythema infectiosum, arthropathy, anemia, myocarditis, polyhydramnios, which is a common pairing symptom to hydrops fetalis. The risk of fetal death is high. However, parvovirus is not known to cause congenital anomalies. As this remains an open question though, in the next slide I have listed 5 popular sources located randomly with higher search indexes addressing the issue of fetal outcomes. Of course, parvovirus in pregnancy is a well-researched subject, and therefore there is a plethora of published findings. Nonetheless, I could not incorporate them all on one slide, so I only quote 5 sources, 4 of which indicate that parvovirus is not a teratogen. It does not cause anomalies in fetus. Only one source mentions congenital anomalies, but that article was published in 1988. Recent studies do not find parvovirus as teratogenic. Here, I list all possible diseases or conditions leading to hydrops fetalis in general, not strictly in relation to parvovirus. I hope that's clear. Parvoviral infection, in particular, develops fetal hydrops through a few mechanisms of its action. By arresting the erythropoietic lineage in the bone marrow, causing aplastic anemia, high output cardiac failure, increased peak systolic velocity, cardiomegaly, and liver damage, all in reference to the fetus. On this slide, I concisely present how to sonographically measure and diagnose polyhydramnios and how to manage hydrops fetalis, which basically includes intrauterine blood transfusion to the fetus, some surgeries in viable fetus based on cardiac and pleural indications, and termination of pregnancy if the gestational age is proper in terms of the viability of the intrauterine patient. Further, intrauterine blood transfusion is a huge problem solver and may 5-fold decrease fetal death incidences. Here I also show medications to avoid during pregnancy. Finally and traditionally comes the legal section, where I analyze 2 published and relevant cases which are followed by the authentic review questions starting from slide 21. The answer key is provided on slide 26. I hope you will revisit the slides through a self-tour once the music starts. Oscar Peterson on Sinatra, my favorite.